When given a rational expression that has a polynomial in both our numerator and denominator, you're going to want to find when you can factor them. So this first one, I'm given a trinomial, and I'm going to use that box method that we did last week to factor it. So I'm going to use my first, my last, and then this is my middle here. My first term is x squared, and I'm factoring this top one here. My last term is 54. And then my middle term is 15x. X squared times 54 is 54x. Now, I need to come up with, 54x squared. I need to come up with two numbers that multiply to give me 54x squared, and then add to give me 15x. Now, I do know they're both going to have an x in them. And now I need to look at my factors of 54. Well, the two that are going to work out here are 9x and 6x. 9x plus 6x is 15x. 6x times 9x is 54x. Let's fill in the rest of this. For x squared, I'm going to break this down as x and x, because x times x is x squared. Now, going across, I need x times something to give me 9x, and it's x times 9 gives me 9x, and then x times something gives me 6x, and we're going to put a 6 here. X times 6 is 6x. Then check this column here. 6 times 9 is 54. Because that works out, when I circle my diagonals, my factored trinomial is x plus 6 times x plus 9. Okay, so let's rewrite our numerator factored out. I've got x plus 6 times x plus 9. And then my denominator of x plus 9 wasn't able to factor, so I'm going to leave it as x plus 9. Now, if you look at both your numerator and your denominator, both of them have this x plus 9. So they can cancel each other out because that is their greatest common factor. When both of those cancel out, I am left with x plus 6 as my final answer.